Hello and good day, pre-algebra. We're going over PO18, solving two-step equations. It is the last objective of our unit, so you can expect a practice test tomorrow and your test for realsies on Thursday. And PO18 is the combination of PO16 and PO17, right? So in PO16, we learned how to handle addition and subtraction in an equation. PO17, we learned how to handle multiplication and division in an equation. And they were each one-step equations because you were only doing one of them, right? It was either addition or subtraction, and then multiplication or division. PO18, we're combining them, okay? You see this first equation, it's got more than one operation in it. It's 5n plus 7, right? And that's why it's a two-step equation, because there are two steps that you'll need to do in order to solve for the variable. Question already? Oh, very, very well. You're just right, okay. So taking a look at 5n plus 7 equals 32, like I said, we see there are two operations. 7 is being added, that's one operation, to the 5 times n. Oh, my editor fired. To 5 times n, times being the second operation there, okay? So we are using opposite operations to solve this, and so we see the operations that are in the equation, and just like in PO16, when we see addition in the original equation, what do we do to undo that? Subtract. The opposite of addition is subtraction. Okay? So our first step would be to subtract 7 from both sides. Right? You start with any addition or subtraction, undo that first, and then we're multiplying 5 times n. The opposite of multiplication is division. Right? And that would be our second step. And that would then bring us to what the value of n is. Okay? So if you understand PO16 and you understand PO17, this isn't really anything new. It's just putting those two things together. And I think actually our first equation that we get to solve is 5n plus 7 equals 32. And so let's do what we just talked about doing. Okay? We're going to start by subtracting 7 from both sides. Right? And again, think of this as that balanced scale, my artwork on display. Right? On one side, we got 5n plus 7. On the other side, we've got 32. And we know that these two things are balanced because that's what the equal sign means. They have the same value. So if we subtract 7 from this left side, what are we left with? We have 5n plus 7. We take 7 away. What's left? The 5n. Just like in PO16, when those two things canceled out, 7 minus 7 equals 0. It's like we have 5n plus 0, right? But we don't have to write the plus 0 because it just doesn't change the 5n. It's still the 5n there. But that's kind of what we have remaining. Okay? So we have 5n equals, and what's 32 minus 7? 25. Right? Now you have an equation that looks very much like what you did in PO17. It says 5 times n equals 25. What this tells us is that whatever n is, 5 of them make 25. But we don't want to know what 5n is. We want to know what 1n is, right? So what do we have to do to cancel out that 5 and get down to 1n? Yeah. Divide by 5, right? The opposite operation of 5 times n, divide by 5, and we get n equals 5. Two-step equation, right? Our two steps were undoing the operations. Subtraction, division, and we get n equals 5. How do we verify that we're correct here? How can we prove to your friends and family that you are right, Anthony? Yeah, if n is 5, then back in the original equation, if we plug in 5 for n and take 5 times 5 plus 7, we should get 32. Well, 5 times 5 is 25. 25 plus 7 is 32. It checks out. We're good. Okay? That's all there's to it. Right? Look at what you have in the equation and undo it. So this next one, 2n plus 17 equals 25. What are the operations in the equation? What do you see? multiplication and addition. So to undo those, we are going to the opposite, subtract and divide. Okay? How do you know which one to do first? Would you subtract 17 first or divide by 2 first? You always want to start with your constant. Okay? And that constant is the number without the variable. Okay? You can think about it like this. We talk about PERMDAS a lot, right? And when you're evaluating an equation, you work through PERMDAS, parentheses, exponents, radicals, blah, blah, okay? Because when you solve for a variable, you're doing the opposite operations. You kind of work through PERMDAS the opposite direction, okay? Any addition or subtraction that you see, that's done first. That's why we would subtract 7 first in the first example. That's why we're going to subtract 17 first in our second example here. When you're undoing an equation, you're doing the opposite operations, you work through PERMDAS backwards. Okay? So subtract 17 from both sides first. We get 2n equals 8. Divide both sides by 2 to get n by itself, and n equals 4. That looks kind of like a y, but I hit the dead spot. It's supposed to be a 4. There you go. Prove it, I say. Okay. Well, take that 4, plug it back in for n in the equation, and does 2 times 4 plus 17 equal 25? Well, 2 times 4 is 8, plus 17 is 25. We're good to go. Right? Good to go. Try that next one on your own. Identify the operations that are in the equation. What do you see? And then undo that. Okay. The only difference between our first two examples and the third one here is that we're subtracting rather than adding in the original equation. So how's it going to change the process? But just give that one a shot. Okay. Undo the operations. Solve for the variable. This is why that process was so important. We're going to be getting to equations now you just can't do in your head. And if you are relying on guess and check, it's going to be tedious, not very efficient. If you need to get your calculator from the phone bin, you can go over and get your calculator from the phone bin. Okay. You too. You weren't on this. You too. Oof. Wow. Okay. So hopefully you've identified the first step here, being adding 5 to both sides. And we're adding 5 to both sides because that is the opposite operation of subtraction. Okay, you might need your calculators again, boys. You might want to hang on to them. Just a thought. All right. Since this is a -5, we're subtracting 5. The opposite of that is adding 5. That's the only difference between the first two examples we did. Right. The first two examples we had addition, so we subtracted. In this case, we have subtraction, so we're going to add as the opposite operation. -5 plus 5 is 0. They cancel out. That leaves us with 12 times n equals 96. Now, this says 12 times n, right? To undo that, we're going to be dividing by 12. And 96 divided by 12 is 8. So n equals 8. Are you sure? Well, I can always check it. 12 times 8 is 96. Minus 5, that equals 91. Booyah. Okay. Questions so far? Okay. Let's take a look at that fourth one. What do you think our first step is going to be here? First of all, what's the constant? What are we going to be undoing first? What's the constant? William? Not 9. Remember that little quirky math thing about -9, okay? So that's what we're going to be undoing first. Peyton, how do we undo a -9?
You're going to do addition.
Right. Exactly. Okay? To undo this negative 9, you'll be adding 9. Now, if it's throwing you off because our variable term is the second term rather than coming first all the time, you can rearrange this if you want to be negative 10n minus 9 equals 41. As long as you keep the signs the same, negative 9, negative 9, negative 10n, negative 10n, as long as you keep the signs the same, you can reorder things, and it's not going to change the value. And that's just optional, right? If you don't want to do that, you don't have to. But if it's easier for you to think about it, if your variable term is first, you can rewrite this to make that happen. But anyway, we're going to add 9 to both sides, because that's the opposite of a negative 9. And now be careful here. When we add 9 to that left side and cancel this out, because negative 9 plus 9 is 0, what's left on that left side? Be careful. Mia, on the right side, it'll be a positive 50, 41 plus 9. But what's left on the left? We add 9. What's remaining? I'm not going to call on you. You're in Adrian's bubble. Anthony. Negative 10n. That oftentimes gets missed. That subtraction sign doubles as a negative sign that belongs to the 10n. Okay, it doesn't just go away. Right? It's a negative 10n. So now our second step, what are we going to be dividing by to get n by itself? Negative 10. Okay? Because our goal is to get 1n, and negative 10 divided by negative 10 is how we get positive 1. Anything divided by itself is 1. Anything divided by itself is 1. Okay? And positive 1, but 1. So 50 divided by negative 10 equals negative 5. Well, how can I be sure about that? Well, let's check it. Okay? Negative 9 minus 10 times negative 5 equals 41. Well, negative 10 times negative 5 is positive 50, and negative 9 plus 50 equals positive 41. It works. Okay? And this check-in can be done very easily in a calculator, right? That's the perfect use for a calculator there to check your answer. But understanding the process of how we got there, just as important. Questions on these 4? Okay, that second row, what changes? We have fractions, which means the operation of division. Okay, so our second step in this case is always going to be to multiply, right? Because we're going to deal that constant first, and then we'll be left with some sort of fraction, division. To undo that, we're going to multiply. So this first one, Gregory, what's our first step here in solving n divided by 4 plus 13 equals 15? 13 minus 13, right? We see the addition there. The opposite of addition is subtraction. 13 minus 13 equals 0. And so we're left with n over 4, or n divided by 4, equals 2. Okay, and again, you can write this horizontally also, if that helps you remember to multiply because you see the division symbol. Again, this fraction bar is the division symbol also, but depending on kind of how you visualize things. In any case, because we're dividing, how do we undo that? Ryan, what undoes division? Multiplication. Okay? So we're going to multiply both sides by 4. I'll do it in red so you can kind of differentiate here. Times 4, times 4. Those cancel out. As opposite operations do, we're left with n by itself, and 2 times 4 equals 8. Okay, 2 times 4 equals 8. Does this work? Well, let's check it. Replace n with 8, so we get 8 divided by 4, which is 2. 2 plus 13 equals 15. It checks out. Okay? It checks out. Try the next one on your own. N divided by 5 minus 20 equals negative 40. Give it a shot. I'm going to give you 20 seconds, maybe 30 seconds. Be looking at those operations and you want to undo them. And then make sure you check your answer also. Just make sure you did it correctly. Okay, so we're working on that one now, that second one. All right, regardless of where you are, your first step, if you want to check that, since we're subtracting 20, your first step is to add 20. This is the first potential mistake here. What's negative 40 plus 20? Negative 20. Okay, if you put negative 60 or anything else, okay, you may have gone the wrong direction. Negative 40 plus 20 is a negative 20. So check that first. Which, if you made that mistake of going the wrong direction, you will eventually catch it when you check your answer, right? It's not going to work, and then you'll say, ooh, something's wrong here. Then you go back and hopefully you find what you did wrong. But now we're at n divided by 5 equals negative 20. And what undoes division? Multiplication. So we're going to multiply by 5. Cancel that out. And negative 20 times 5 is a negative 100. Prove it! Okay. Negative 100 divided by 5 minus 20. Well, negative 100 divided by 5 is a negative 20. And negative 20 minus 20, we start 20 away from 0 and go 20 further. That brings us to negative 40, which is exactly what we wanted it to equal. Okay? How are we feeling? Okay? Good? Next one, and if you feel good with this, you roll right ahead. Feel free. Your homework will be the second page here. So if you are feeling like you don't need to listen to me anymore, go ahead, show your work. You can work ahead. We'll go over a few more examples if you need it, but you can rock and roll. Kira, if you're done, did you show your work? Yeah. Excellent. Excellent. Then you can do something else. All right. This next one, n divided by negative 6 minus 4 equals negative 15. Similar to our previous example, we do have that subtraction. That constant, we're going to start by adding 4. Right? You want to get rid of that non-variable term first, that constant term. Negative 4 plus 4 equals 0. And so now we have n divided by negative 6. Careful with this addition. Negative 15 plus 4 is a negative 11. Right? Negative 11, not negative 19. Negative 11. William. I'm confused on this one. Yeah. What's your question?
How do you get a negative? Because a positive negative times a negative is a positive.
Like in this step now? So in this step, William, what are we going to multiply by? Negative 6, right? So times negative 6 times negative 6. Here they cancel out, just like they're supposed to, ends by itself. And now a negative 11 times negative 6 is what? A positive 66. Okay? Well, if we're not sure if that's right, what can we do? Check it, right? Plug 66 in for n. 66 divided by negative 6, right? Replace that n with our value. 66 divided by negative 6 is a negative 11, and negative 11 minus 4 does equal negative 15, so it checks out. Okay. Yeah, sometimes negative signs, they can make things a little bit confusing. So checking your answer is the best bet. Trust the math, trust the rules, then check your answer. Does that clarify things now?
Yeah.
Good.
I thought it was a positive -6.
Yes. Then lastly, 3 plus n divided by 9 equals 0. Again, this is your variable term second, so if that throws you off, as long as you keep those signs the same, positive n over 9, positive 3, you can reorder them to be n over 9 plus 3 equals 0. You can just reverse them. That's okay. But we're going to start with that constant. So it's a positive 3. To undo that, we're subtracting 3. 3 minus 3 equals 0. We get positive n over 9, and 0 minus 3 is a negative 3. Okay. Scarlett, what are we doing next here? Sorry, you were probably working on another one, but yes, very good. Multiply both sides by 9. Right? Cancel out that denominator. N is by itself, and negative 3 times 9 is a negative 27. Are you sure that works? Let's check it. 3 plus negative 27 divided by 9 equals 0. Negative 27 divided by 9 is a negative 3. And 3 plus negative 3, which is the same thing as 3 minus 3, equals 0. It checks out. Folks, we're on a roll here. We're 8 for 8. Excellent job. Questions, comments, concerns, complaints, compliments, congratulations, criticisms on this? Okay. Your assignments for the morrow. More practice. Okay, you've got 12 of them here. You are doing exactly what we did on the front side. Anthony, do you need to show your work? Yes, you do. What work do you show? The same work we showed on the front side. Okay? That whole time I was modeling for you the work I want to see here. Show me you're undoing the operations. Show me you've checked your answer. All of the things. Pay attention to signs, things like that. And then down at the bottom here, it says write a two-step equation with a variable value of 5. Write a two-step equation with a variable value of -1. And then write a two-step equation with a variable value of 7. What does that mean? That means that you need to write a two-step equation like we have above, so that when I solve it, the variable equals 5. An example, 3n plus 2 equals 17. Right? Because when I solve this, subtract 2 from both sides, 3n equals 15, divide by 3, n equals 5. Right? That's what I'm looking for here. You need to write a two-step equation so that when I solve it, your variable will equal 5. Okay, for the second one, same kind of thing. When I solve it, your variable needs to equal -1. Third one, same kind of thing. When I solve it, the variable needs to equal 7. Okay? We good? We good? All right, you've got 11 minutes to work in the spirit of 11 Christmases. Use your time wisely. That's how you math, folks. And show your work.